Hello student, so let's start revising today from electrostatics. So we are going to revise all the formulas and important points of electrostatics. Okay, so let's begin electrostatics. The first formula, first important point is Coulomb's law. So the force, electrostatic force of interaction between the two charges is given by K Q1 Q2 by R square. Suppose you have any two positive charges, so the force, they will be repelling each other. They are placed at a distance r. The magnitude is q1 and q2. It's a central force. It is acting along the line joining the two charges. Second is electric field intensity, which is given by symbol E, right? So due to any point charge, suppose you have positive charge, its magnitude is q. At this point P, you want to find the electric field intensity. So you know that electric field line is going away from the positively charged particle. What does it mean? If you place here any test charge, due to the presence of this positive q charge, it is going to move away along the line joining the two charges. So electric field intensity is equal to the force acting on unit charge q naught. Okay, its unit will be Newton per Coulomb, and if you want to write in magnitude, so that will be kq by r square, right? Now the next is electric dipole. Electric dipole is made of two equal and opposite charges placed at a distance 2a. We have kept it 2a so that we can easily calculate. In numericals, it is easy to take 2a. Okay, and for the formula derivations also. So 2a, it is always acting from negative to positive, the electric field intensity, the dipole moment, which is P. So P is equal to Q into 2a in magnitude. Fine. The fourth formula is electric field intensity on axial line of the dipole. Suppose you want to find electric field intensity on the axial line. Axial line means along the axis. So here at point P, we want to find electric field intensity. This is 2a. So this distance from the center to the point P is taken as r. So when we derive the formula, which I have given in the derivation booklet, that is equal to 2kp by r cube. K here is Coulomb's constant. I forgot to mention that. It is 1 by 4 pi epsilon naught. Okay, epsilon naught is the permittivity of the free space. Next is electric field intensity on the equatorial line of the dipole. So that is, suppose you take here negative, this is positive charge, this is the diagram. So the distance between them is 2a. At point P, I want to find electric field intensity. So when we see the net electric field intensity comes in this direction. So if you want to write in vector form, that is minus 2kp by r cube. Yeah, मैम just एक बार pause कीजिए. Next is when you place an electric dipole in external electric field, so torque acting on the dipole is, suppose this is the direction of electric field, you have placed here. So the torque acting, the angle between the electric field and P is, here you must take the negative charge, because due to this it is always acting from positive to negative direction. So the force acting on it will be in this direction. So this is QE and this is QE. The direction of dipole moment, electric dipole moment, will be from negative to positive. So the torque formula which we derived was PE sine theta. Yeah. Next, Gauss's theorem. So, which is the charge, the electric field intensity or the electric flux passing through any closed surface, that is given by E dot ds. Okay, and this electric flux is the charge enclosed by the closed surface times 1 by epsilon naught. That is Gauss's theorem. Now, using Gauss's theorem, we found electric field due to a charged conducting shell. So this is the charge conducting shell. Suppose its radius is r. Okay, and the total charge present on the surface is q. So E is equal to outside. Suppose you want to find at this particular point P. So the radius will become, for the Gaussian surface, should enclose this charge. So the red dotted line which I am showing you here is the Gaussian surface. This distance between point and the center of the sphere is r. So it is kq by r square. That is outside. Now E on the surface here, the Gaussian surface and the surface of the charged conducting shell will coincide with each other. So that will become kq by capital R square. And you know that E inside the shell is 0. The electric field intensity inside the shell is 0. If you have to plot a graph, it will come like this. The variation of electric field from the center of the charged shell, hollow shell. So inside the shell it is 0 up to radius r, and then it is maximum on the surface, and then it is inversely proportional to r square. So E is inversely proportional to r square. E inside is 0. Okay. Now coming to the next one, the ninth point is E due to a long charged wire. The formula we got for this is 2k lambda by r. Lambda is linear charge density, that is charge per unit length. This is uniformly charged infinitely long wire. So due to this wire, if you want to find electric field intensity at point P, which is at distance r, so that has come as 2k lambda by r. K is nothing but Coulomb's constant. So if you have to plot a graph between E and R, it came like this. It's inversely proportional graph. So yes, the next formula is E due to a charged plane sheet, uniformly charged sheet, electric field intensity due to uniformly charged sheet. So the Gaussian surface was cylindrical in this case. So this was the diagram we were making when we were deriving the relation for this. At this point P, I want to find the electric field intensity. So that has come. E is equal to sigma by 2 epsilon naught. It is independent of the distance from the charge sheet. Sigma here is surface charge density, which is Q by A. Right? So till here we have finished Gauss's theorem, Coulomb's law, electric field intensity due to an electric dipole on axial line and on equatorial line. Okay, so in the next session we are going to discuss about electric potential and electric capacitance. Okay, thank you. All the best.